We're going to do another example related to finding the angle between two vectors. Here are our two vectors, and good thing, we don't have to find a formula, we don't have to draw anything, we can just do the math here. So to find the angle between, this is our setup. So it's going to be the dot product between the vectors divided by the magnitudes multiplied together of the vectors. And then we're going to do the inverse cosine of it. So if we go through the math on this, we're going to be doing cosine of theta equals the dot product of this and then divided by the magnitude. So the magnitude of this vector times the magnitude of this vector. Okay, so dot product is multiplying essentially the x's together. So you got a 2 times 6 plus a negative 6 times 2. And then the magnitude of this is kind of like finding a Pythagorean theorem. So those would be like the legs of this, and we're trying to find the hypotenuse. So we're going to be square rooting 2 squared, which is 4, plus negative 6 squared, which is 36. And then here we're going to be 36, so 6 squared plus 2 squared, 36 plus 4. So the top gets us a 12 plus a negative 12. And then this is the square root of 40 times the square root of 40, which is 0 over 40, which is 0. Okay, so now we are trying to do the inverse cosine of this. So 0 is fine, but we're going to do the inverse cosine of that. So the inverse cosine of 0 is 90. So 90 degrees, and we have a saying for that. There's something that means. That means that these vectors are orthogonal. And orthogonal means that they are perpendicular to each other, aka perpendicular. So in the vector realm of physics and Calc 3, and this world comes back up again, that you'll have 3D spaces potentially, and you're trying to figure out if these vectors are orthogonal, and you're going to be looking at if the angles make 90 degrees. And so for us, this is our equation, and if we get a 0 out of it, we're always going to have something that's 90, and then they're known as orthogonal. And so even if you drew the picture on this, and if you drew this vector of 2, negative 6, so if I drew that vector and I compared it to 1, 2, 3, 4, 5, 6, 2, they even look perpendicular, just kind of drawing them. And actually, if you talked about slopes, so if you did the algebra part of this, if you talk about the slope of up to over 6, and you compared it to this slope, which was down 6 over 2, they are opposite reciprocals of each other, which also makes them perpendicular. So all this stuff all kind of works together, but I don't always want to draw a visual. Sometimes I can, but sometimes some of the information is just too much and too complicated. So we do have a formula, and if it equals 0, and you're going to do the inverse cosine, you're going to always get a 90-degree angle out of that, which makes it orthogonal.